Lately, I've noticed something about myself. Every time I come across an impressive project, I immediately start wondering what technology is behind it. Usually, it's pretty easy to figure out. You open the game, you look at the graphics, you watch the animations, and after a few seconds, you can already guess what they're using. Unity, Unreal, Godot, the usual stuff. But a few days ago, I came across Messenger, and during the first few minutes, I thought exactly the same thing. At first glance, it looks like a pretty normal indie game. You control a character, you explore an open world, there's dynamic lighting, other players connected, animations, physics. Everything seems to fit exactly what we'd expect from a modern game. But there was one detail that kept bothering me. All of this was happening inside a browser tab. There was no installation, no launcher, no updates. You simply opened a website, and you were already playing. That made me ask myself something. What's really happening behind this screen? For years, we've associated browsers with websites, forms, and relatively simple applications. But Messenger completely challenges that idea. So I decided to investigate. And the more I looked into it, the more interesting it became. It turns out that this project was created by Vicente Lucendo and Michael Sungaila under the independent studio Abeto. And the most interesting part is that they didn't choose the easy path. In fact, you could say they chose the exact opposite, because when most studios want to build a 3D game, they usually rely on an existing game engine. It makes perfect sense. Unity gives you physics, lighting, animation systems, editors, tools, pretty much everything you need. But Messenger works in a completely different way, and this is where the story starts getting really interesting. Because a huge part of what we're seeing is built on top of Three.js and WebGL. And if you've never worked with these technologies before, let me explain them in the simplest way possible. Three.js isn't a game engine. It's more like a toolbox. It helps you render 3D objects inside a browser. But it doesn't solve everything else. In other words, it helps you place a tree, but it doesn't build the forest. Which means that many of the systems we normally take for granted had to be built specifically for this project. Now, while I was researching the game's architecture, there was one decision that immediately caught my attention. The planet. Most people see it as an artistic choice, a small, charming little world. But from an engineering point of view, it's actually brilliant. Think about almost any open-world game. Sooner or later, the player reaches the edge of the map. And once that happens, developers have to come up with some excuse to stop you from going any farther. Massive mountains, infinite oceans, invisible walls, whatever works. Messenger solves that entire problem with an incredibly elegant solution. It turns the entire world into a sphere. And suddenly, the edges disappear. You can keep walking for minutes, and eventually end up exactly where you started. The best part is that a relatively small map suddenly feels much larger than it actually is. It's one of those design decisions that seems simple, until you realize how many problems it solves. But while I was exploring the planet, I noticed something else. I wasn't alone. There were other players. And that's when the conversation became much more interesting. Because rendering 3D graphics inside a browser is already difficult. But rendering those graphics while synchronizing multiple players in real time, that's a completely different level. Every step, every move, and then be sent back to every connected player. To make this possible, Messenger uses WebSockets. Basically, a permanent connection between the browser and the server that allows information to flow instantly in real time. It's one of those technologies that most users never even notice. But without it, the multiplayer experience simply wouldn't exist. And the more I analyzed this project, the more obvious one thing became. Messenger isn't impressive because it's huge. It's impressive because it's incredibly efficient. It manages to accomplish a lot using surprisingly little. That led me to look at another piece of information that completely surprised me. Its download size. Looking at the game, you'd probably expect hundreds of megabytes, but the reality is completely different. Messenger loads an incredibly small amount of data compared to most modern games, and that tells us a lot about the philosophy behind this project. They didn't solve problems by throwing more resources at them. They solved them by designing better. And honestly, I think that's exactly why Messenger fascinates me so much. Because it's not just another video game. It's an engineering showcase. It's proof that there are still developers pushing modern web technologies to their absolute limits. And perhaps the most interesting part is that most people will open Messenger, spend 5 or 10 minutes delivering letters, walk around the planet, maybe meet another player, then close the tab, without ever thinking about what made all of this possible. But behind that seemingly simple experience, there's an enormous amount of engineering. Engineering that's almost completely invisible, and that's exactly why I wanted to make this video.